Hey everybody, this is Ahmet. I work as a data scientist in Salesforce for about the last 10 months. Prior to Salesforce, I was a senior data scientist on LinkedIn, and before that I was a software engineer in Google. Today, originally I wanted to talk more about the architecture of what we have been building for the last 3 quarters in Salesforce, which was specifically focusing on how to put the Lambda architecture together with Kafka, Spark streaming, ML machine learning libraries, and so on. Unfortunately, that itself is still under the vetting process, and it's been taking a little longer than anticipated, and I cannot just go out there and explain the specifics about our architecture without getting an approval from the HR. So I'm going to more focus on the application part of how we use our platform with a very specific use case, in this case, which can be generalized as I will go on, where, for instance, taking one of the applications out there and how to make it as a feature and incorporate into your generalized machine learning models. And in this case, I would like to talk about how to use sentiment analysis as a means to an end in machine learning rather than a standalone concept, because I think it's actually been widely used, but widely used only for very, very simple use cases. And then, of course, I will try to be like as brief as possible in terms of the concepts, and I have no intention of actually digging deeper in any of the technical aspects. If you're really interested in anything about here or about the Lambda architecture that also that pretty much supports this entire thing, feel free to reach out to me after this, email me, and I would be glad to talk about it. All right, so let me start with what I'm not going to talk about today. I'm definitely not going to dig into any of the specifics and details of what other technologies that actually support these things, like latent semantic indexing, like specifically democratization of data and so on, like NLP. Those kind of stuff basically are building blocks of your general architecture and machine learning models. However, those you can also dig deeper, find online sources, and easily catch up rather than listening to them. And just showing the formulas over here in this presentation, though can be useful, I think is not the best use of our time. I think the best use of our time would actually be seeing the result of what we can apply and how we can apply, and the crucial part of making it as a data product. So in order to do that, what I want to cover is that first go over the working definition. So for the rest of the presentation, it actually makes sense whatever we're saying. Again, I'm not going to dig too deeper into the technicals. I'm just going to very, very briefly, to the point, talk about what sentiment analysis is in a nutshell, and very, very, very specific application of machine learning to give an idea on what it is, so that we can basically move on the working definitions and actually get to the point. I really wanted to show a short video clip about one of my favorite actors, Sacha Baron Cohen. Not one of his favorite movies, unfortunately. The Dictator wasn't that great of a movie, but he had a fantastic clip over here that pretty much shows the ambiguity, where unfortunately we do not have audio, and I just found out about that, so the clip won't make great sense. But if I were to summarize it, basically he enforces that both the words positive and negative to be from now on used as Aladdin, and then pretty much the doctor is giving the news to his patient as your HIV Aladdin, and the patient's face you can pretty much observe. So this satirical thing is just a little funny, the fact is that, and I can guarantee you with everything I've seen in Google, everything I've seen in LinkedIn, and so far in Salesforce as well, all these complex applications and stuff you see machines are actually really helpless sometimes. Like, you wouldn't believe the things that they get confused about. Like, seriously, just like how this particular word just makes you confused. Am I HIV positive or negative? Luckily, hopefully, you don't even go to that step. But like what I'm saying is, machines are pretty much helpless in a lot of concepts and a lot of things where we think things are brilliantly intelligent is basically somebody, in some sense, just splits up the dimensions so the machine can make a better decision, and that's it. Like, it's basically putting like 10,000 like children in a room and like assigning each one of them some of the stuff, and hopefully they will coordinate well and something will come out of it. Most of the cases it's better than expected, at least, but like, they're not really intelligent, unlike what people want to put into. And I wanted to point that out. Now, the working definitions, as I promised, I'm going to just cover two things for that very briefly and move on. So for those of you who don't know what sentiment analysis is a very specific and broadest application of it is built on these 4 steps. Step number 1, you pick a question, a binary question, or perhaps a ternary question with an answer. The question can be, so assume that you're this like worldwide famous like shoe brand. You just came up with a great new shoe, let's say these shoes, which are knitted, and nobody had a knitted shoe before, but you actually don't know how people will react to it, right? So you launched it, it's been a month, 2 months, you're really curious. I mean, you have some sale numbers, but you have some sale numbers in a particular small location where you didn't even go around the world, and you just want to find out. What you do is that you start with a question. Without a question, nothing you build will make sense, right? You first need an objective. In this case, your objective is, does the public like our new shoe line? A very simple question with a yes or no question. Yes or no answer, right? And then you find a relevant data set that has the opinions about these things. And in this case, for instance, let's say that these shoes are sold in Amazon. So you go to Amazon, you check every single review where people bought this shoe and left a review on Amazon. And let's say that you find, since you're trying to find out whether like people like the shoes or not like the shoes, the question basically comes down to, okay, the good reviews, let's say 4 and 5 star reviews, and bad reviews, 1 and 2 star reviews, and you separate them out. And this is in machine learning jargon is what we call label. So you have labeled data set of people's reviews, right? And hopefully, and you assume, which kind of makes sense, that people who give 4 and 5 stars talk good stuff about, mostly good stuff about your product, and 1 and 2 stars talk mostly bad stuff about product, why they don't like them, right? So you try to learn from these aspects. And how do we learn? What is the learn? Let's make it extremely simple that we can explain to our grandmother what machine learning is in this concept. You learn, let's say, how a particular word, for each word in the dictionary, how many times it appears in the good ones and how many times it appears in the bad ones. Chances are the 1 and 2 star reviews are not going to talk about your shoe where they use the words like awesome, fantastic, comfortable, where the 4 and 5 stars are more heavily going to use it. And you basically gather these things. And what we call in machine learning jargon, again, is the features in this case. And finally, the real thing that you're doing, you go out in the world that you know nothing about. What we talk about, these labels that don't exist, right? Let's say you go to Twitter, you go to Facebook, you go to places where people express opinion, but you have no idea what those opinions are. Like, are they good opinions, bad opinions? You don't know. What you do is that you apply whatever you learned from step number 3 into what you see in step number 4. Basically, every time a review that has more of the words like awesome, comfortable, good, you pretty much think that, okay, these are pretty much good reviews, these are pretty much bad reviews. And finally, you do the analysis on your data. In which regions people like my shoe? How many people like my shoe? Like, if I separate into genders, like, is there a difference? Do the males like my shoe better, females like my shoe better, and so on? So in a nutshell, this is what sentiment analysis is, the broadest application of it. Hopefully everybody is with me so far. All right, so here is a fantastic paper from Pang et al. From Cornell and IBM from 2002, where they actually did ditto whatever I told you into movie reviews, and they found out about like words like dazzling, brilliant, phenomenal, and excellent as like positive words from many humans like this, and then they found cliched, terrible, unwatchable, stupid, slow. Although I don't know why slow is a bad word for movie reviews. That's just my taste, I suppose. I love French movies and they're all slow. Anyways, so they gather these, and then finally they apply it to people who they already know whether they like it or not, pretend that they don't know, which in this case is what we call a test group, and they find out how accurate what they were doing is. Granted, this is 13 years ago experiment, but even then, back at that time, this was basically wow kind of thing. So it was really good, and it really took a lot of people off the mind. And if you want to see more recent applications, actually, all you have to go is go and take a look at the previous presidential campaigns, and almost all of these like presidential campaign analysis were actually done in sentiment analysis parts, where all over the social network they were going, both Democrats and Republicans were going around finding out every time something happens, how the Democrats like react to this, how the Republicans react to it, and how in general public like this, and so on. And you can extend these use cases, right? I mean, I'm pretty sure you can come up with more and more. All right, so this is what sentiment analysis is. We have one more working definition, and then I'll actually get to my actual point. So the next point is machine learning 101. Don't worry, again, I'm not going to dig into deeper and just try to explain something like pretty much completely, like there are like 16 statistics books can be written about this, and you would still miss out some parts. But let's go to a very specific application where, again, we can explain it to our grandma, and my grandma can say, oh, this is machine learning. So if you can achieve that, then that's enough for this presentation purposes. And then you can follow up afterwards if you're also interested. So basically what it is machine learning is all about building programs with tunable parameters. And in most cases, these parameters are some values, some numbers, floating point numbers, that are adjusted automatically. Let's underline the word automatically. So once you tune these, once you come up with the data, these parameters you don't tune. It's not like radio buttons. Hopefully the machine will catch up and find out what the values of these things are. And how it does it? So that it improves their behavior by adapting to previously seen data. So that the actual tuning is happening to previously seen data, even though this definition looks a bit weird. Like if you look at here, what we did was pretty much that as well. Number 3 was the previously seen data, the Amazon reviews, and then we basically apply, like tuning was the finding out the words and their relativeness to good or bad review, and then we applied it on 4. Right. So let's take a look at an example of this. Consider red and blue lines, red and blue dots as like different classes in this case. Let's say one is good review, one is bad review. Mathematically, actually geometrically, all you want to find out is draw a really good line that actually can separate the blue points from red points. If you can geometrically do this, then you can basically say that everything on this side of the line are the good stuff that I want to find out. Everything on this side of the line are the best stuff that I want to find out. And this is basically the most simplest way of explaining a classification in machine learning. And of course, there won't be just one line, right? The ending green line versus black line both does the same thing, but they're different lines. So there are multiple ways to reach to the same mathematical conclusion, just like how Bing and Google reaches to different results from whatever you're doing. It's just they're both trying to do the same thing. They just have different set of previously seen data and different optimization parameters and different runs, and they end up with different lines. And of course, in this case, it looks perfect that you perfectly separate these things. In real life applications, that's generally not the case. And if you look at the architecture chart on the bottom left, you can actually see how this plays in. So you have training text, documents, and images, and I'm going to go over the sentiment analysis use case to do a one-to-one mapping in this case. You can consider them as Amazon reviews in our case, right? So this is what we call training because we learn from these. These are previously seen data. And then labels, as we talked about, is like good start or bad start articles. And then feature vectors, as we said, the features are what we identify from. We don't take the entire document and put it in a blender and come out with something, right? I mean, Google, when you're searching for something, Google doesn't take all these like web pages and like just like scramble and take out. It actually pinpoints what you're looking for and finds out if these web pages have those words or have those images or people like you visit. Anyways, I don't think I should get too much into Google details. I guess that might be NDA, but regardless, so these are the feature vectors you get. In our case, again, if I were to go over that, it would be these words awesome that extracted from the entire review. Review has a lot of stuff. Maybe they're giving their life story about how they went to this shoe store and like met their love of their lives and stuff. But at the end of the world, all you extract as a feature vector is the way they describe these shoes, right? And finally, you do the machine learning algorithm, like basically separating out how these words play in what you're looking for. Is it a red, is it a blue, right? On the bottom, you see this new thing, something that somebody shared in Twitter about your shoe line, or on Facebook on your web page about this shoe, and you take the exact same words, the feature vectors, and you try to find out if whatever you learned before correlates with this, and then finally you have the expected label whether these people like it or not. I'm really, really hoping that everybody is with me so far, and feel free to like raise a question if I'm skipping anything or if you think anything over here is confusing. But all I'm trying to say is that machine learning is basically just like how we did in a sentiment analysis example. Look at all the data that you have seen before, try to learn something from it, and see if you can apply it to the things that you don't know so far. That's it. And everything else is just blah, 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 right? Like, you don't have to dig more into deeper. All right, so let me get to a point. My points, not just a point. My point here will be that, so we built this platform where we get real-time data. Anytime anybody does something, we just extract that, and then we try to extract the features and so on, which I'm not going to be digging into like in this presentation, as I told before, because of the vetting process. But what we do afterwards is actually an interesting part, which I wanted to cover, is that you have all these features, right? You have all these like words, awesome and stuff like that. But how do you use them? Like what most people actually do is that they take these features and they just heard some machine learning algorithms. They heard that logistic regression works great. Let's put everything there. Let's see if it gives me a number. And honestly, these are just mathematical computations. This is just like logistic regression is just a linear regression, which is you basically put values in there and it will spit out a number for you. No matter what you put, it will spit out a number for you. And honestly, like if you're just putting everything you find out over there and expect to like depend on this spitted out number, bad things are waiting for you, my friends. I'm going to tell you. A lot of people who built great machine learning applications that failed, those failed because they actually did not understand their features. They did not understand what they were putting in there. And what I want to say here is that it is actually a product decision on what you want to put there. And here I'm going to go over a sentiment analysis as one thing over there. Just plug it out, plug anything else in your mind that's useful for your applications, and everything I say here will be applicable. And hopefully by the end of this presentation, I'll be able to convince you guys. If I'm not, I'm a bad presenter. Oh, what can I do? All right, so consider this, right? Very, very simple case. Let's say that we only have two dimensions. We know something's price, we know something's quality, and let's say that the field squares are the things that we want to reach. Let's say they are the good reviews, and empty squares are the bad reviews. Okay. If we go back to our previous example, how are we going to draw a line that actually separates the field squares and the white squares? Frankly, there is no way, right? Geometrically, you cannot just draw a line to do this. And there are more complicated machine learning approaches to deal with this, which I won't cover, but like for instance, you can use a polynomial thing where you can just draw a circle, and then everything in the circle, everything outside the circle, or you can use kernel functions and stuff. But these are basically, if you see a specific problem, you deal with it. There is another way, right? Clearly, the field ones and on different levels on this dimension. Now we can actually draw the line. In this case, since it's three-dimensional, it becomes a hyperplane that separates the filled ones and empty ones. And this might just seem too abstract. Don't worry, I'm actually getting to a specific application in a case study where we use it right now. As you know, Salesforce has like close to 200,000 customers where they basically keep our data in our platform and so on. And sometimes, not all our customers, but sometimes our customers actually want insights from our capabilities on the data that they are already storing. Right? If they're already storing their data in our cloud platforms, why not actually get more assistance and better things that we can do with that and give them insights? So in this particular case, think about a broadband company, no name, just a broadband company that actually gets customer case assignments. And what they're trying to do, their objective, is to assign this customer case to the best customer representative. And that's it. That's what they want to do, right? So we have Leah on the top. She's technically talented, has a wide spectrum of knowledge on the existing issues. And we have Jonathan on the bottom. Both of my colleagues, by the way, and they both have this, like Leah has this hairstyle, Jonathan has this hair. What we do here, and if you go back to our case study again, this time slightly more different. As you can imagine, this multi-billion-dollar broadband company doesn't just have Leah and Jonathan dealing with all the customer cases, right? They actually have hundreds and hundreds and hundreds of like customer representatives. Now the question goes to, even if you know that the technical questions should go to Leah and then communication related or the other complaints go to Jonathan, and if it's in the middle, I can create new features to separate out dimensions. That's we covered, right? Perfect. But we actually have hundreds of Leahs and hundreds of Jonathans. Even if you know it should go to a Leah or a Jonathan, which Leah are you going to choose? Which Jonathan are you going to choose? This is a real problem, right? It's a real problem. So you actually not only want to optimize the right kind of people dealing with this, but also want to optimize how to choose among all the right kinds who should get this. Let's go to a case like this. Let's think that we have two Leahs and two Jonathans, and we are now separating them into three different dimensions. The dimension number one, how good are they dealing with angry customers? And we look at the past performance. Leah number one is 60% of the time successful on dealing with angry customers. Leah number two is 20% successful on dealing with angry customers. Dimension number two, how fast are they serving? Dimension number three, and again, in this case, Leah number two wins. She's much faster in dealing with cases. And dimension number three, since Leahs are more technical representatives, what is their technical capabilities, how good they are in this particular thing, right? And likewise, we have the same thing for Jonathan, where the third layer is overall communication skills rather than the technical skills. Now, if we have cases such as these, now it comes down to this broadband thing that, like, what do you want to optimize for? You want to optimize for everybody. Every customer complaint goes to the right person and dealt appropriately. Correct? Correct. That's great. But what if you actually have one more additional thing that you want to do, which is, I also want to serve these customers as fast as possible because I have huge amount of complaints, which broadband companies do, unfortunately, right? I just want to deal with them as soon as possible. And all of a sudden, you have two objectives here. And then all of a sudden, your machine is a bit confused who to assign these things, right? In this particular case, I added angry customers because the angriness, as you remember from the previous case, we can detect from sentiments, right? So what we can do here is, first of all, identify the angry ones. First of all, of course, we identify if it's technical, non-technical. And then we identify the angry ones. And then let's say that the angry ones that actually goes to the Leah that is very good at dealing with angry customers, even though she's slower, right? However, please help me fix my modem, which is not necessarily, we're not losing this customer. And we probably want to help her out immediately, which a better representative with better technical skills and like faster approach is a better candidate for dealing with this kind of customer. So the point I'm trying to make here, if we wrap up, is that like in most of the applications you have, I can guarantee you, if you think hard enough, you don't have one single optimization. Even for the cases where your moneymaker products, chances are you just don't want to make money. Yes, you do want to make money, but you also don't want to lose. You also don't want to lose your customers, right? So maybe you want to keep the customer satisfaction up while getting ad clicks. One very simple example I can give you is that if your Facebook feed is all of a sudden filled with a lot of clickbaits, then chances are there will be more clicks for Facebook, and they're going to, in short term, make some money. Unfortunately, they're going to lose half their customers, and instead of 1 billion, they're going to have half a billion people visiting their company, and eventually it's going to hurt them. So chances are they actually want to optimize for multiple things. Okay, so let me wrap up. Again, I use sentiment analysis in this case. Just use it as an X, and then consider your applications and anything that is more relevant for that thing. But if you're getting out of this room with one thing in your mind and one thing to remember, that is that when it comes to big data, there's immense amount of power that you can process things, a lot of things you can do that actually makes people really, really, really relaxed. That, oh my God, like I have this perfect AWS cluster with 200 machines. I can do any processing I want. Let me blend in everything. And then all of a sudden you have a mediocre machine learning application. What I want to convey here, and please just get out of this room with this one takeaway message, is that think more about what makes sense for your applications in a product sense, rather than pulling in every information you have out there. And that's pretty much it, I believe. We're almost running out of time, and I would like to reserve the last 3-4 minutes for your questions. This was the conclusion. Probably, I don't know if you guys know, there's some company breaks guitars thing. One of the airline companies broke a guitar of a customer. Instead of dealing with them properly, they just shrugged him off, and then he wrote a song that became viral, and it actually eventually cost the company $160 million in business. So smart decisions save you money is the point I wanted to make. And if you have any questions, feel free to reach out or here as well. I did not know. I just got a message that in the last couple minutes. So, right. Hope this was not too boring or nothing out of your expectations. And thank you so much for listening.